Good afternoon, everybody. Thank you for coming. This is a Kotlin session, and my name is Andrey Breslav. I'll be very happy to tell you about my project. So this is a modern programming language for JVM, as it was originally designed. Now it's not only for JVM, but for JavaScript as well. So we have two platforms we compile to. And this is like an advanced introductory talk, meaning that I will adjust the material according to your interest. So if you ask no questions, it will be boring. I'll just give you very silly examples. And so go ahead and ask questions whenever you like. I'll start with very short motivational part, and we'll quickly proceed to code examples and all the relevant stuff. So the greatest question for any programming language designer would be, why are you doing this crazy thing? Nobody ever designs programming languages from scratch, right? So our context is JVM. And if you think about the Java platform as a whole, it was started in 1995. And since then, it has gained lots of popularity, primarily as a platform, as an ecosystem of many libraries, many frameworks, great virtual machines, so on and so forth. So, and all that progressed pretty good over time. So now we have a really up-to-date platform, but the language didn't progress that well over time. So if you remember 1990s, my monitor looked something like this. And this may be not a 1995 design, but 1998 design. And this is what I would call Java, which is a great language of its time. So if you consider the state of the art, it is a little bit ahead of what we have on the Java platform, even of what we will have in a year from now with the great Java 8 coming and rescuing the world. So there is a lot to be fixed or reconsidered, and we're trying to do that. So we're aiming at something I like to formulate as a modern language for industry, meaning that we want to be up to date in the sense that we want to be smart enough to handle your code properly. And I think the main challenge there is to have in your code enough information for the human being to understand what it's doing, and not much more. So if your compiler is much more stupid than you are, it's bad. And we're trying to fix that problem. The biggest thing there is to have right abstractions provided by your language, so that you don't have to repeat yourself over and over again, going over the same like coding pattern or the same idiom, because you just can't abstract it over and put into the library. So the point there is to be able to abstract such things, put them into the libraries, and just call them instead of recoding them by hand over and over again. And industry is our real-life setting and our main constraint. Because you can fantasize about so many interesting things, that you can automate this and fully analyze this and have completely safe code and everything. But as soon as you consider like 30 people working on the project of millions of lines of code for 10 years, it's all a little different, because we get to read much more code than we write. And it has to be maintainable by not only by the discipline of the coders, because it's long history and people may, vary their attitudes. So this is our constraints. So if you take JetBrains as an interested party here, we have our code base, 10 years old, written in Java, having tens of thousands of classes there, and we would really like to have a language to take this whole code base without rewriting it, just adding new things in a much nicer way. Does that make sense? Any questions? Objections? All right. So there definitely is a question, or a set of questions, why not this or that language? I have some names called out here, but you may be interested in some particular one. So ask me why not about whatever you like. Why not ML? Very easy, not Java compatible. Why not Scala? So we tried Scala. We actually tried a few languages before we started our own. Our two biggest problems with Scala is one philosophical, relying on implicits so much that you don't see so many things in the code that are actually there and working for you. And this has lots of implications of different sorts, but I think the most important is this comprehensibility implication, where you have lots of things expressed in a very powerful way, but in such a way that you don't see them. So for a large project, it can be a real disaster. Also, this has implications on performance of the compiler, performance of the IDE, so on and so forth. But these are like technical details, and the biggest issue there would be just the readability of the code. And then another thing is more technical, but still pretty important. There is no Scala IDE today, and it's been a long time since people started to doing those IDEs. Scala people are doing their IDE for 8 years by now, I think, and we are doing ours for like over 4 years already, and nobody got anywhere. And this is a very alarming thing. I mean, we may be very lazy and not doing the Scala plugin, but Scala people are doing their IDE pretty well. And it seems to be an inherently complex problem to develop an IDE, which suggests that to comprehend the language is a very difficult task, even for a computer. Yeah, so this is, in short, our problem with Scala for our setting, having a huge code base and many developers, so on and so forth. More questions like this. What about Groovy? So Groovy is actually a whole different story because it's mainly a dynamic language. So Groovy 2.0 has this nice feature of static compilation, which to me mostly turns it into Java with a little bit of syntax additions. So Groovy is ideologically a dynamic language. So if you want to use it in a groovy way, it will be dynamic, thus slow. So you can't actually run a huge code base and you can't run anything like an IDE written groovy, just because by nature it can be fast. And also with dynamic languages, there is another problem. If you have a huge project and you want to refactor it, you're just done there. I mean, you can do it by hand, of course, but this is the only way you can do it. And yeah, this is strongly against our culture to refactor anything by hand. So yeah, Groovy is not our way. Yeah, so Kotlin is primarily a static language, so we are planning to maybe at some point add dynamic types to handle some interesting situations, but this is not like the main focus of the language. Main focus is statically typed, type-safe language. More questions? All right. Then just a short explanation of where we are now. Kotlin is not yet released. We have open sourced the project in February this year. And currently we're going through a couple of milestones before we get to the beta stage. The current phase is M3. We have most of the features prototyped and working. There are very many bugs to fix and very many performance problems to fix. But we're approaching this beta phase where it's going to be a stable compiler, usable for production, and we're going to use it at JetBrains at that point. But we're not going to commit to this design as like something we're going to maintain backwards compatibility for. So we're first rolling it out at JetBrains for internal evaluation. Of course, it's open source and everybody can use it, but the point is to evaluate it in an industrial setting and then specify anything and release. Because before you actually try the design, you can't be really sure that it's good for your setting. Questions here? All right. Go ahead. What's the relation between Kotlin and MPS? MPS, metaprogramming system, is another more research project by JetBrains. It's a language workbench where you can create your languages which are not actually textual but look like textual, and you can extend them in a nice way and easily. There is no connection between these two projects. We learn from each other like more in the requirements part, not the implementation approaches. So these are two parallel projects. MPS is more like a research thing, although there are production projects in production that are written in MPS, and there are none in Kotlin Git. So yeah, these are two parallel things. Okay. More questions? All right, then I proceed to the code. Yeah, so I'm using my IntelliJ with the Kotlin plugin here. And here's the first example. Any questions? No questions. OK, so here's one thing I would like to point out about this program. The code is organized into packages, and we have a function which sits right under the package. So a function in Kotlin doesn't have to be inside a class. It may be just a free function, like it is here. Now I'll just quickly demo basic syntax, and we'll proceed to some interesting examples. So I'm creating a class here, class called greeter with a function greet, and saying hello. Google, this is what a class looks like, pretty straightforward. And here I create an instance of this class and call this function. And we have code navigation, all the basic IDE stuff already. Another thing I would like to do is to show how variables look like. So this is a local immutable variable. If you know Scala, it looks familiar. And many other things look familiar if you know Scala, Groovy, C#, Java, or many other languages. So we learn from our colleagues in different groups. So here is an immutable local, and this is now an immutable member. And one more thing I'm adding is a constructor parameter. So here is my primary constructor declared right in the header of the class. So this variable here can be used inside the initialization code. Like I can put it here, and it will be inside the value of this s variable. I'm renaming s to something more reasonable. Does that make sense? Any questions? Go ahead. The question is, can I call this from Java? Yes, I do. Yes, I can. So if I just create a Java class here, can I? OK. So here's my Java class. And I say new greeter. Here it is, even in the completion. And I can say greet, and I have to pass something here. We'll say hello Java to me, hopefully. Have an error. OK. I have to put something here too. Is there a default visibility to what? Oh, OK. All right. Yeah, so let me explain this. First of all, visibility of classes and everything else. By default, it's internal. Internal means it's private to your module. A module is this entity here. So Kotlin examples here is my module. So it's wider than a package. About return types. So this field here, it's actually a property, not a field, actually has a type, but it's inferred. So you can say string explicitly or just omit the type because it's inferred from the right-hand side. For a function, if you don't declare anything here, you just have unit by default, which is returning nothing interesting. It's like void, but a little better than void. It's a proper type. So by default, you just get unit. If you want something else, you specify the type. Go ahead. The question is, how do you call Kotlin's package level functions from Java? Let's have a function here. Here's function foo. And from Java, so this package actually is compiled down to a class with static members. So if we have a look at the bytecode, this is what it looks like. Let me just put it here. And here's my foo. It's just a public final public static function in my package class. And the class has name hello, hello.namespace anyway. So if I say here, hello.namespace.foo. There it goes. More questions?
How do you get around class?
If you name a class namespace, you just don't parse because it's a keyword. Or do you parse? Oh, that's a shame. All right. Yes, you do. Sorry. It's, yeah. We used to call packages namespaces, and at that time it didn't parse. Now it should be an error, but it's not there yet. Yeah. I'm, having my times mixed up. Sorry. More questions? Printline is a function in our library package which is imported by default. So here it's just implemented like this, and the package is Kotlin IO, which is just by default here. More questions? The question is, are functions first-class objects that you can pass around? So yes and no. So currently we don't have syntax to just refer to function name as a value. It will be there, but it's not there yet. And you can't pass a function around if you wrap it into an anonymous function and pass that as a value. Because anyway, to pass things like functions around on the JVM, you have to create an object. What the function types look like. Okay, I'll get there in some minutes. I'll be demoing that. Go ahead. Yes, there was an inline keyword, which I'm not sure is right on that function, but it's not a keyword, it's an annotation. Another not yet implemented feature, which will probably be in Kotlin like 1 point something. The point there is that we want to support inlining on the compiler as a compiler capability to eliminate closure allocation. Sorry. In many situations, that would be very beneficial. When you inline the whole function together with its arguments. And the JIT can't do that. So we want to do that ourselves. JIT can't inline the call together with its argument. Yeah. All right. So should I proceed to the next thing? Okay. So that was a boring thing. Another boring thing comes here. So this is a class which is analogous to something like this. So this is a Java class whose peculiar property is that it does nothing, even doesn't fit on the screen. And this is unfair because you have to like repeat yourself all over again, like first name, first name, first name, first name, first name, and first name here inside parentheses. Not bad. You really convinced the compiler that you want that first name. So we're trying to work around this problem somehow. And this is a very bad piece of Kotlin where you say first name, first name, first name 3 times. You don't want to do that. You simply declare your 3 constructor parameters here, and then you have 3 vals in the class, and you just initialize them this way. So you can get the same result by saying vals, by putting vals right here. This way you just get a data class, basically, something that holds your data and does nothing else. And it doesn't say anything else, which is probably good. Questions? The default? Why wouldn't we make having a val here a default? Well, it's I don't think that an average class only holds data. So there is an option of saying whatever you pass to the constructor is stored there, but it would be making implicit the fact of allocating a new field in your class, which is a little bit against our beliefs. So we're trying to make all the relevant things explicit. If you want some data to be stored in an object, you have to say that it's stored there. So this val tells you that it is stored, not just used for initialization. Yes. Yeah. Mm-hmm. Okay. So currently, so for this exact class, equals and hashcode are just inherited from the base class. But if you say that this is a data class, data is just an annotation that tells the compiler to generate a few convenience methods. it automatically emits the correct equals, hash code, and toString. Doesn't matter. Okay, the question is, how do you specify whether this first name has setter or getter or whatever? So if you say val, it means that you have a field which nobody sees. It's a private field. You can't access it. And you have a getter. So if you say val, you have a getter. If you say var, for a mutable thing, you have a getter and a setter. You can even customize those, but in the body of the class. Yeah, so if you want to change types of things and store mutable references to mutable objects internally and expose them as immutable things, it would be necessary to have two names declared for that. So a private property holding a mutable version and a public thing for a read-only version. Yes, you can. Yeah, but one thing there is that the getter has to have the same type as the property. You mean, okay, yeah, it was a misunderstanding. So for me, a read-only thing has a read-only type, like a read-only interface. And you want only to decorate the return value. Yeah, sure you could. Yeah, okay. Yeah, this you can do. Go ahead. You can provide your own annotation. So we don't have a fixed API yet to program a compiler plugin that handles the annotation. But the architecture, overall architecture is there. So you can declare your own annotations and put them there. It's just a class name. So I think I can even navigate to it. So here is the data annotation. It's a class somewhere. Yeah, any annotation that's applicable to this kind of declaration. Yeah. Well, to me, it looks better this way. And we are actually going to make public also an annotation just to get rid of the stupid keywords. So it looks right. Yeah, they can have constructor parameters, and you can just put them there. Okay. So I'll demo some syntax here. Actually, not syntax, but use cases for different kinds of functions. So this is how you create a list, like a list literal. In Kotlin, this array list is just a function with a var arg parameter, and this is how you iterate through a list. Should be pretty straightforward. Okay, now let's do the same thing with the map. It's a little bit more fancy syntax. So we have a function hash map that just takes a sequence of pairs, and this to function takes the left thing and the right thing and makes a pair of them and passes that to the hash map. So you can construct a map just by passing a bunch of pairs there. Then a map can be accessed with square brackets, which are actually just calls to get and set methods. So these are just convention calls. Most operators in Kotlin are treated by convention. So if you say minus, it's actually a method called minus, called from somewhere, declared somewhere. And same for square brackets. Square brackets for reading is get, and for writing is set. So here it's a call to the set method on a map. And this is how you iterate over a map. You can declare a pair key and value, and say for those pairs in your map, you want to process every pair and handle it somehow. The question is if we have overloading. Unfortunately, yes. If you have multiple getters, they would have either different types of parameters or different numbers of parameters. All right, so in your square brackets, you can put many arguments. So it will just overload, it will perform the overload resolution on this call. That's it. Are the generic types erased? Unfortunately, yes. The question is, can you confuse a map for an array because it has numbers as keys? Yes, you can, and I don't think it's bad. Yeah, so an array access looks exactly like a map access or whatever access, like a list access would look the same way because you have a get method on array, on list, on map, on whatever. And a string access will look exactly the same. You have a string and you say string square bracket I, and it will be a character with this number. Good point. Yes. Yes. Currently, any class that declares a method called get can be accessed with square brackets. Well, we are going to restrict this a little bit with demanding an annotation on the get that says, okay, this is an operator, not just a function, to manage this somehow. But yeah, generally the idea is that you can make any class into supporting this get convention. 2 is a function that looks like this. I'm not explaining this A right now. It will be in a few seconds. But basically, it's a function that takes A and B and returns a pair. OK.
In-text operators generally.
All right. The question is, if we have primitive types, yes and no. So for the language itself, it doesn't know about any primitive types. It thinks everything is classes. But when we generate Java code, we actually have primitive integers there and primitive doubles and stuff like that. So it's purely an implementation detail over JVM. The question is, could you use a primitive where as a type argument? Yes, you could. And again, on the JVM, it would be integer for int and character for char and so on. Exactly like Java. Yeah, we box, unfortunately. We can avoid a little bit of boxing sometimes, but not much of that. Yeah, this is a platform-specific thing. We can't do much about it. OK, a short explanation about arrays. So arrays are quite an unfortunate story on JVM. So we have 9 array types in the language. One is array of T, which is an array of whatever objects. And other 8 are int array, char array, whatever other array. So if you want an array of ints, you say int array instead of array of int. If you say array of int, it will be array of integer. So this is not very nicely looking, but I think arrays are actually low-level implementation optimization tool. So you don't really want them in your APIs anyway. So if you want something nice and shiny, you'd better use collections anyway. So this is not a huge loss, although I would like them uniform, but we can't do that. Great question. Thank you very much. So the question is this a tuple? I'm going to answer it in a second. So here is my next example. So that was not actually a tuple. We have dropped tuples like a few weeks ago because they are not needed. So this was something else. We call it a multi-declaration, where you can assign something to a number of variables. So how it works is, by the way, note that this is Java AWT point, which is just an existing class, not a Kotlin class. So the thing is that if you say x and y gets point of 1 and 2, it gets compiled to x gets point of 1 and 2 dot component 1, and y gets point component 2. And component 1 and component 2 should be some functions available on the point class. The problem is that the point class doesn't have those functions declared in its class file, but we have something called extension functions. Here is the illustration of what they look like, which lets you extend your classes with static methods like here to make them those methods available after a dot. So I can say for this point object, I can say point of 1 and 2 dot component 1. And this is all you need to be able to say x comma y gets point 1 of 1 and 2. This component 1 is declared here. It's a special kind of function definition syntax. So you have a func keyword, then you have the receiver type point, and then after a comma, the function name. This means that this is an extension function that takes its first argument on the left of the comma. It's purely a syntactical convention, not anything like very fancy. It's basically the same utility function you would put in your point util class, and it's implemented as a static function. There is no like altering the class at runtime or no dynamic dispatch or anything. But still, it makes this kind of syntactic convention possible, where you say whatever has a component 1 after a dot will be able to use this multi-declaration syntax. And the same holds for many other language conventions like fors and stuff. I'll show that in a second. Questions here? OK, so here we are declaring two variables, x and y. These are OK. Yeah, thank you. That's a great question. The question is, where does this x come from? It's actually this.x. And this is, as usual, the object you're called at. Right, so this is just the receiver of your function. All right, yeah, so we're getting into a little bit of confusion. So this is implemented as a static function. It actually belongs to this package. It's not in the class, but it's declared to have this point receiver type. And this makes the compiler create a variable called this inside this function of this type. And that's it. So it's not a member of the class, but it has the same syntax. And you can pretend you are in the class. Although you, of course, don't have any access to private members, for example, or anything like that. But the syntax is the same. Yes. If you declare, if you have more component functions, it doesn't invalidate this two declaration syntax. You're able now to say z, x, y, and z gets point or whatever, but you're not prohibited to say x and y. Currently, we do not allow you to skip a component, so this wouldn't compile, but we will do that. Yes, unfortunately, yes, it's not only public, it's mutable. Yeah, you could, of course, say this.getX or whatever. Yeah. Yeah, so this is what AWT looks like. They have public mutable fields. Can't help it. OK. Another concept gets on stage. The question is this like aspect-oriented programming? Well, yes and no. Aspect-J had this intertype declarations where you could say, OK, this method now belongs to that class. But the difference here is that in Aspect-J, that method actually got to that class. So you would alter the bytecode of that class at runtime, or even statically, and actually push the method inside. We don't do that. We only have the syntax that reminds you of that one, but it's not exactly the same thing. Yeah, good question. Why dropping tuples and why not using general pattern matching instead of this silly convention? I'll answer it in a second. Let's go over maybe easier questions. Yeah. OK. I wouldn't say it's compromising the language design. So it turns out, well, it may sound a little bit hacky, but it's not. It turns out that we want to extend existing APIs by our own functions, because we tend to operate a lot on existing data types, for example. Yeah, and the natural way of saying I want to call this on that object is say object dot this function. It has a bunch of advantages, one of which is you can say this object dot and get the whole API in your completion list, unless you're using Vim or something. But yeah, some people use IDEs actually. So this is one thing. Another thing, I have a demo for that. I was planning to show it later, but you're predating my demos. So here is a piece of Guava, just to show the difference between the two approaches. So Java's collections don't have proper, at least today, don't have proper methods for transforming and filtering. So what the only thing we can do is to create this collections2 class and have transform and filter there. And so this is how you transform and then filter a collection. This is the best we can do without this extension mechanism. But with an extension mechanism, we get something else. We can say list.filter.map or transform, whatever you call that. And the huge difference between this and that is that here, what you say is transform a filter of a list. And the subject list is lost somewhere in the middle. And your operations are getting backwards. As opposed to here, where you say list, transform it this way and then that way. So it gets you the right understanding of how you actually process the data. And I think it's important. Yeah, did I answer the question? All right. Thank you. Now we're getting back to, oh, okay. It is a static function that takes a point as an argument. So it's a component one of point. Almost. Yeah, so it's basically like a function of the class. There are two differences. First of all, you can import it or choose not to import it, and then you don't have it. And second, you cannot override it because it's static. Okay. Mm-hmm. It's all static. So if you have component one declared on object, it has an implementation that will be run. Whatever it does, I don't know what's the component one of the object. But anyway, yeah, it's all static. All right, so now back to the tuples question. Let's have a look. So there are two huge usages for tuples. One is returning multiple things from a function. Another is pattern matching. First things first. So here is an example of returning two things from a function. So I want to parse a file name and a line number from a string. Here it is, and I just assign it to a pair of things here. So this is what my function looks like. I say I return a location, and then I do some regular expressions and say location of whatever. I return a location. So what would be the difference with returning a tuple? If I could say, by the way, a pair of whatever string and int here. So what's the difference between returning my location and a pair? There is a huge difference. A pair is some object with two properties there, first and second. And I have no idea what is first and what is second. So when I call this, I have to navigate back to the declaration of this function and see what is first and what is second to figure out what to do with them. And my location has proper names for the components so that I never get lost in those orderings and stuff like that. So it's documented by default, by definition. So I think this is a huge advantage of name things over tuples. We thought about having decent tuples with labels, which are mostly like records already, that actually store the naming information in the type itself. But those are so much like classes that it's funny to have this concept in the language alongside classes.
And the value and the error code really have nothing to do with each other. And you're adding sort of talking to overload programmer, try and think of some concept that defines different things that have nothing.
Yeah, I agree. So if we could actually return multiple things from a function physically, that would be great, and we would probably struggle for something else. But underneath, we anyway have those classes. But the point is different. Yeah, so the point is that if you have some two unrelated things, like your actual return and an error code, how do you relate them with a decent name? Yeah, there is a problem there. I agree. But this is the only problem, and I think it's having this problem is better than having an extra concept in the language which is totally separated from everything else and duplicates much of the functionality anyway. Right? Okay, yeah. Yeah, so there is an interesting argument. So okay. All right. So the point is, what if I really need a tuple, right? Like I want to put my values into map, or like a key maps not to one value but to two values. For that, you have a pair class in the library and a triple class in the library, and you don't have a quadruple class, because if you have quadruples in the code, you can't read that code. Yeah, so the performance argument you're making, I don't quite understand, because to put anything into a map, you have to either alter the map implementation or to have an object there. I don't know any other way. If you specialize, yeah. If you specialize, yeah, if you tell me how to specialize properly, I will be very grateful. But let's take that offline. Okay. All right, so yeah, and the same trickery with multiple declarations is used for, say, indexed iteration over a string, for example. We can say that a string.indexed gives us an iterator that returns those pairs of things. And here is a usage of a pair. It's a proper class, not too harmful if you are not using it as a standalone object. This should be pretty straightforward. I won't give any details about this. Any more conceptual questions or objections? I'm getting lots of objections here. This is great. The question is, if we are going to have Kotlin-specific reflection that would properly reflect our new concepts. Yes, at some point we will. So currently we only put annotations on those functions in the Java sense, so that you can actually recover that information, but we don't have the library that would do that nicely. But the plan is to implement that. Yeah. There was another question. Yeah. Okay, good. All right. What comes next? I showed you the collections already. Yeah, so a little bit more on the collection story. So there are many different approaches to collections, and it's customary for different languages to say, whatever platform we run on, collections are so important that we redo the collections and have our own incompatible with the Java collections, because those are, bad and mutable, stuff like that. So we're trying to stick to Java collections, because transforming your data all the time is costly and inconvenient. So we have those vanilla Java collections we provide extension functions to equip them with all the needed functionality, and we do something else on top of that. Something else looks like this. So here is a piece of funny code. Please tell me what's wrong with it. Actually, it's nothing wrong, but you should suspect that it's wrong. I have a print function that takes a list of any. Any is an object, like the top class. And then I call it here on a list of ints. Is it bad? Yeah, so Java wouldn't let me do that because I could say list.add of 1 here, for not 1, but of string here. But the trick is that my add does not resolve. There is no add. The reason is that I'm not running on a Java's list per se, although at runtime it's just a Java's list, but on something else. So Kotlin's collections look like this. Can you see this? Okay, so we have split the collection interfaces into read-only and mutable versions. These are all erased, so in the bytecode it's actually java.util.list, but for the Kotlin compiler it's a read-only iterable, read-only collection, read-only set, read-only list, and then we have mutable versions derived from those. So that in the Kotlin type system, you can actually distinguish between a read-only interface and a fully-fledged mutable interface. And Java classes are seen as extending those mutable versions. And in Kotlin, you can derive your own classes from immutable versions. Does that make sense? These are not the same things. I meant read-only. So these interfaces do not guarantee you any immutability. They just don't have mutation methods. So these are read-only interfaces. These are mutable interfaces. And you can derive your own immutable collections from the read-only interface. And we are planning to provide you some easy way to reuse the existing immutable code from Java to declare that it's actually extending the immutable read-only iterable rather than a mutable iterable. Questions? Okay, so this is pure compiler fiction. Yeah, nothing is actually happening at runtime, but you can have this properly covariant list, and the dream comes true finally. The user stops wondering, why can't he pass a list of ints where a list of any is expected? Isn't it a list of any, after all? Yes, it is, if it's not mutable. So that's OK. Good. That was easy. Now let's turn to something rather different. Here is a piece of Java code. This is Java, not Kotlin. We don't say that public static, whatever. And this code is problematic because there is a risk of runtime error. This file.list files would throw a null pointer exception if the file does not exist or is not a directory. And this is why lots of enterprise code gets covered with those null checks like all over the place. We have check that for null and that for null and maybe that also. And it may be pointless, maybe not, but it's definitely a very, very, very funny thing to guard, because you don't know what happens, to guard against everything. So we're trying to manage this somehow by making the compiler actually watch your nulls and telling you when you have to do anything about it. So it's the same Java IO file here, and we call list files, and the compiler knows that it's nullable. So if I say files.size, it will warn me. Actually, it won't let me compile anything. It will just tell me that I have to do something about that null before I dereference the files variable. So actually, this files variable has this type with a question mark at the end, which is a nullable array type. And if you have a nullable type, it means that you either have an array or a null. And if it can be both, you can just dereference. So what you have to do is either check, say, if files is not null, then you can. Or you can do many other things, actually. You could say, if files equals null, then return. or so on and so forth. Please ask questions here. Go ahead. We're explicitly doing analysis to trying to try to figure out the nulls. Yeah, so this is actually a very straightforward data flow analysis that is built into the type system, basically. Yeah, and we support it for nullable types to know where we can dereference variables and where it's risky. Yeah. All right. Let me show you a little bit of it. So if you want to say if is null of x, then do something. This won't work unless you inline that function. So if you inline it, we can actually run the analysis on its body. Otherwise, it's not safe to say it's actually checking for non-null. One other thing is that instead of saying return here, you could say fail, which is like JUnits fail, and it still will work, but for a different reason. Fail says just throw in a legal argument exception, and it actually has a type. And I hope my ID can figure it out. And the type is nothing. So for this only for this type, we know that it's a special type, it's an empty type. So if you manage to compute a value of that type, you're probably not in the control flow anymore. So it's equivalent to explicitly throwing an exception or returning from your scope. So you're guaranteed not to have a null pointer on a dereference here. Make sense? Let me repeat this. So currently, we're not inlining anything, so we're not looking at bytecodes anywhere. For fail, we're looking at its type signature because it returns this special type. We know that it will exit. When we do inlining, we will look at the implementation, whatever it is, bytecode or just the code inside the function, and figure out the data flow there. Oh, all right. So this is a different story. By default, everything from Java returns null, but there is a catch here because this is not just a default. By default, that would be a nullable array of nullable file. So this function is currently manually annotated. So we have those annotations for JDK and many other libraries. And you can add annotations yourself, but we're currently working on a tool that infers them automatically. So there we are looking at the bytecode of the JDK, and we're thinking about flipping that default after learning how to infer proper annotations. But currently, yes, the default is that everything is nullable unless you annotate it explicitly. So say at JetBrains, we're using, in Java, we're using annotations nullable and not null all over the place. So it will be easy for us. And I had seen lots of nullable and not null in Guava at least. So maybe Google uses that as well. OK. More questions? Oh, go ahead. The question is if we can use nullable and non-null annotations for compiler optimizations. Unfortunately, I don't know about many ways of using them at all, because it's again, it's on JVM. You just have references there. They're always nullable by nature on the virtual machine level, so you can't optimize much there. OK. Another bit on this same static analysis we're making. Yeah, so this is a school example of like a silly interpreter of expressions. We have an expression class here with two cases of number constant and a sum of two expressions, and I want an interpreter. So this is a very bad Kotlin code again. We have an eval that takes an expression and returns an int. And I check if e is a num, so is just an instance of check. If e is a number, then we create a new variable, we cast, and we call what we want on that variable. Well, this is really annoying, so I'm not doing this. In Kotlin, what I do is just this. Compiler is smart enough to figure out that we have checked for this num here, and we can now use the variable as if it was of that type. Make sense? Good. No questions here. that's great. And the same, of course, can be done for some as well. And if you think about it, it's very similar to like pattern matching in a way. So if we do that in a different syntax for like switch statement, which we call when, here is another version of the same function. So what I'm saying here is when e is a number, use it as a number. If it is a sum, use it as a sum, otherwise throw an exception. So this is our like poor man's pattern matching. We don't do fully fledged pattern matching because we're not convinced it's really necessary. Probably 80 to 90% of the cases are covered by this. Because if you look at pattern matching in functional languages that have them, that have this feature, you encounter so many patterns like num of e of v and then use v, which is absolutely equivalent to this, where you just don't have to capture the name because you have the name here. So we are trying to get away without doing pattern matching because it's a huge complex feature and it would be nice not to have it in the language. And if it works, we'll be just fine like this. Yeah. Type refinement, not really. We propagate through the control flow if it doesn't get too crazy. So we actually propagate less than we could. Or am I right? Sorry, no, I take that back. We used to propagate less than we could because we used to declare variables this way, like somewhere in the control flow. But this is not there anymore. So now we propagate as much as we can. So it's inside a single unit of data flow, like inside a function or inside a constructor, things like that. And there, yeah, we just take the whole control flow graph and propagate the data over it. Well, I wouldn't say it interacts in any way because function overloading happens on declaration level and this happens on expression level. These are pretty disconnected way. I see what you mean. Yeah. So if you have an ambiguity because of when you have a function that is overloaded, like you may be of A and of B, and you're statically of A and you're checking for B, and then just saying f of x, what would that be? F of A or f of B? So since this is confusing, we just say ambiguity there. We just don't tell you, don't do anything and let you choose, because otherwise you will be confused either way. Yeah, so we could take whatever default, but the user will be confused. Yeah. It's an explicit return because here is an equal sign, and this is an expression that returns whatever, that evaluates to whatever is on the right-hand side of this of the arrow. Go ahead. It can be any expression.
Okay, and so then if we have like paired on first, and paired on first always
in case of paired at first, it will, because we know that it cannot be mutated in any way. But if it's, say, a mutable property, it wouldn't be learned for a new type because it may change. Yeah, so if you the customary practice here is that if you want your information to be stored there, even for, say, a function return value or mutable property return value, you just assign it to a local variable and then check the variable. Oh, by as foo you mean like SQL, like declare a variable of this name? No. We are thinking about finally getting a let expression into the language, but that's hard. I'm a little bit out of time already, so I'm wrapping up the official talk, and we'll have Q&A. So the bottom line here is that we have a powerful language with, I think, very good set of abstractions that are facilitating our Java interoperability in a nice way. So if you're interested in anything about Kotlin, you just go for our homepage, which is kotlin.jetbrains.org, and there you have all the documentation an online demo, things like that. So please come and give us your feedback, maybe contribute if you like. We'll be just happy about that. Thank you very much for your attention.